Hey there, somehow it is just another video of me solving randomly problem. So we have to clone a graph today, and we need to create. We have to return a deep copy of the graph. So we are given a reference to a node, right, in a connected undirected graph. So undirected, so connected means we're not gonna have a node like this, right? It's the graph is the whole graph will be connected in some way. And then the second thing that it is undirected, which means there's no pointer, right? So if one can get to two, then two can get to one, bidirectionally. Okay, so um we can have a we can okay, so we can use both depth first search or breadth first search to do this. Um, but I wanna use the breadth first search in this case. Okay, so we can use a queue, right, to keep track of the node we are currently processing. We can add one, the root, right, to the queue at the beginning. And then we also need a hash map, right, um, to keep track of the original node to the clone node, right? Okay, so this is the clone. Or just put it here, clone. And this one is the original node, original, right? Okay, so this is our graph, right? One, two, three, and then four. Okay. So the reason what we are storing this is because we're gonna look at the neighbor, right? And then when we are at two, we also have to look at the neighbor back to one, right? Right. So it's convenient to store the original node to the clone node, so we don't have to creating the duplicate node. So let's say we are processing node one now, right? So one is in our queue, of course. So we pop it off, right? Pop it off. So it means we are processing it now, right? So we look at the neighbors. So okay, at any point in time, the node in the queue, right, is already being cloned, right? One is in the queue, which means one is already being cloned even before we're processing it, right? And when we process one, we want to add the neighbors, right, to its neighbors in neighbors array, right, right here. Right? So they're gonna have an adjacency list, right? You can get to their neighbors. Right? So we look at two, right? We're gonna check, right? We're gonna add the two in the neighbors array of one, right? So let me do this. Let me do this. Let's just pretend um we have a neighbors array here, right? For one, two, three, and four, right? And each starting out at an empty array, an empty array, right? Because we also want to clone like the neighbors, right? Okay. So whatever is in the queue is already being cloned, right? And what we are trying to do now is why we're trying to build up their neighboring array, right? So we look at two, okay? Um, so we want to add the clone node of two, right, in here, right? Not the original node, but the clone node, right? So we're gonna check our hash map. Do we have the clone node of number two? No, we don't, right? So now we need to create the clone node, right? So two, and pink mean the clone node, right? Then we need to add it to our queue. to process it later, right? To build out the neighbors of 2. Okay, and after that, after we build it, that we can add the clone node into our array, our neighbors array. Thing means clone node, and then yeah, we keep going. So now we look at 4. So is 4 in here yet? Right? No, we don't see 4, so we have to clone 4, right? Okay. So after we clone 4, we can add 4 to the neighbors list of 1, 4. And I also need to add 4 to the queue for further processing, right? Okay, so that is node 1. We are done with node number 1, right? So now we look at node 2. Okay, we pop it up, right? Which means we are processing it now. So we're gonna look at the neighbors, right, of 2, which is 1 here, right? So we are building out the neighbor list for number 2 now. So is 1 already in the list? Yes, we have 1, right? We have the clone node of 1. So that is convenient, right? We don't have to clone it again. We can just add it to our uh, neighbors array of 2. And then we look at 3, right? Is 3 in the list, in the map? No, right? So we need to create 3, right? We need to clone it, okay? Now we clone 3, right? We need to add it into our queue for further processing, right? And then we need to add 3 into our neighbor list of 2, 3, right? So we are done with 2 now. So now we process 4, we pop it off, right? We're processing 4, right? So we look at the neighbors of 4, which is 1, where we already have 1, right? So we can access the clone node through the original node, right? So this is 1, and then we process 3, right? Look at 3, okay, is 3 already cloned? Yeah, it is, right? So you can get the clone node of 3 um, through the original node, right? So now we are done, right, with 4. And so we pop off 3 now, and we process 3, right? So we look at 2 neighbors, right, 2 and 4, right? 2 and 4 is already cloned, right? So we can just add it directly into our um, neighbors array of 3. Okay, so that is our algorithm for breadth first search. So let's code this up. So in the worst case, right, if we don't have a node, right, you can just return no. Okay, so we need a graph on the map, right? And then we need a queue. I have a custom queue here, right? So that using TwoStack, right? So that I can have an amortized shift at 001. You shouldn't use the plain array to build out the queue because shifting at the front will gonna cause that O(n), right? So we have to push in the root, which is the first node, and then we need to, so whatever inside the queue, this has to be cloned, right? We can do graph the set the original node, right? Which is node to the clone node. So new node, something with node value. So y queue is empty. Queue is not empty. Then we can do something, right? And at the end, we can return graph, right? But yet, passing in the original node, right, will give us the clone node. Make to the pop, and then the clone node is graph get node. Okay, so we are getting the clone node, right, from the original node here, right? And now we have to build out the neighbors. for the clone node. So the original node dot neighbors, right? Not for each neighbor, right? So if the graph doesn't have the neighbor yet, we will create ones, right? The graph dot set neighbor to which is the original node to the new node, right? Which is neighbor dot value, and then we need to push it in the queue for further processing. And then we need to add it to the neighbor list. The push grab the get neighbor, right? So we get the clone node from the original node, right? And then we're trying to build out the neighbor list for the clone node, right? So clone dot neighbor dot push graph dot get neighbors. So the neighbor here is the original node, and then graph dot get neighbor will give us the clone node, right? I'm gonna push it into the neighbor list of the clone, the current clone node. And then if that doesn't exist, right? Yet, if the clone node doesn't exist yet, we just have to create it, right? And then put it into the queue to process it neighbors list later. And yeah, that's pretty much it. Let's give it a try. It work. Thank you for watching.